Hi everyone. In this video, we'll try to understand what are variables, right? So variables are nothing but placeholders, right? It's nothing but a placeholder which actually stores a value, right? So what do I mean? Let's say you have a variable x, okay, and you're storing 5, okay? So variable is nothing but it's just storing this value 5, right? It is just storing this value 5 inside this, right? So it can store any value, right? It can store, let's say you can write x is equal to 10 or x is equal to, let's say, ABC, right? So it's just storing a value, right? So let's take an example. Okay, let's say you have a wardrobe, right? Let's say you have a wardrobe. Okay, what is the use of this wardrobe? Okay, so it's basically used to store clothes, right? It is used to store clothes. Okay, so you can assume that wardrobe is a variable, right? And the value are the clothes, right? So simply, so this is the value and this is the wardrobe, right? These are the clothes and these are the variable name which are storing it, right? So variable name is x and x contains this value 5, right? So that is what a variable is. Okay, you can perform different operations on this, right? You can perform different set of operations. Okay, so now let's try to understand. Okay, so in some languages you might have seen uh, 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 different data types, right? Let's say in some languages you might have seen that we specify the variable through int, double, right? We write int x is equal to 5, double y is equal to 5.0. Whereas in some languages we just write x is equal to 5, right? Or var x is equal to 10, right? So we are not specifying the data type, right? So these two things are known as, so in languages where we have to specify the data type, so this int is nothing but a data type, right? It is nothing but a data type telling you that what you will be storing, right? What you will be storing. So these languages are statically defined data types, right? Static defined data types, where languages like where you don't have to specify anything, right? You don't have to specify anything. You can just store the values, okay, without specifying whether it will be storing an int value or a double value or a string value, right? Those languages are known as dynamically defined data types, right? So it is known as dynamically defined data type. Okay, so some examples. So Java and C++, okay, are statically defined data types where you have to actually specify the data type of the variable, right? Okay, and dynamically defined data types are languages like Python and JavaScript, right? You don't have to specify anything, right? You can just write x is equal to 5, x is equal to ABC, right? And it will directly store that particular value, right? You don't have to specify what is the data type that you want to store, right? You can directly do this. Okay. So the reason why it happens, right? So first let's understand compile time and runtime. Then I'll explain you why it happens. So compile time. Okay. So we have a compiler, right? We have a compiler. So whatever piece of code we write, right? Whatever the piece of code we write. So if you make any syntax mistakes or something, that gets checked during compile time, right? That gets checked during compile time. Let's try to take an example. Let's say normally print is should be in small, right? But what we do, we write it in capital words, right? We write it in capital. We write the P in capital, right? Or we write all the letters in capital. Okay, so the compiler will understand. Okay, this is not the correct syntax, and it will throw an error, right? It will not execute. Okay, and it will throw an error, right? Or let's take an example. One more example. Let's say you are trying to open a file, right? Let's say you are trying to let's say you're trying to print a colon or something, like the colon should be there, right? But let's say you forgot to put that colon, or let's say you forgot to put a curly brace, right? Or you forgot to put the correct indentation. So these errors are logged during compile time. Okay, so runtime is what? Runtime is opposite, right? So runtime, you're not able to figure it out whether it will throw an error or not, right? It will throw an error or not. Let's say you're trying to open a file, right? Okay, so you're trying to open a file. Okay, so right now the compiler does not know whether the file is not there or not, right? So after, when it starts executing, it will check whether the file is there or not, and if the file is not there, it will throw an error, right? It will throw an error. So these things are known as runtime error. So let's take one more example. Let's say you are trying to do x is equal to b by a, right? So right now I don't know, or the compiler does not know whether this is correct statement or not, right? So if, let's say, the a value is 0, right? If the value of a is 0, then during runtime only it will get to know what is the value. Okay, that time it will throw an error, right? So how are these two things linked, right? In static defined data type, okay, during the compile time we actually allocate memory, right? So when we write int x is equal to 5, we actually allocate memory during compile time, right? So all these variables, all these data types, they have a specific set of memory, right? I'll tell you about that, right? So that happens during compile time, right? And in languages where we don't have to specify anything, right? We can directly write where we can write directly x is equal to 5 or something, right? This so memory allocation happens during runtime, right? So this happens during compile time, and this happens during runtime. Okay. So there are different advantages, disadvantages, right? Compiler, so this takes a bit more time during compiling, right? But the running of the code will actually happen very fast, right? The running of the code, because compile time is like something which we can still bear with it, right? Because once it has been compiled, once the code is correct, okay, what will matter is runtime, right? Let's say when you open Amazon, right? So Amazon has the code is already working properly, right? Now whatever you search, that is runtime, right? That is runtime. Okay. You basically get the output during runtime, right? Let's say whatever you search, let's say you search a pencil box, the things will be shown to you in runtime, right? So now this thing, since the memory allocation happens during runtime, it's a bit slower, right? So it has a very negligible difference, but because of this factor, right? Because of this factor, it's a bit slow, right? So there are other things also which takes into consideration, right? So this was one of these things: compile time and runtime, right? So now the memory allocation happens during compile time, and this happens during runtime. Okay. Now let's try to understand, okay, what memory I'm talking about, right? So every data type has some set of memory allocated to it, right? So int is of 4 bytes, right? So int is of 4 bytes. A double is of 8 bytes. Okay, 8 bytes. Similarly, a character can be of 2 bytes or 1 byte, right? Depending upon the language which you coded, right? So Boolean is of 1 bit, right? Boolean is of 1 bit. Okay. So what is an advantage of this? So what is an advantage of this? So let me tell you. Okay. So you guys might have seen an operating system, or you might have seen that our operating system or the computer only understands things in terms of zeros and ones, right? Okay, it understands only things in terms of zeros and ones. Okay, so every byte is of 8 bit, right? Every byte is of 8 bit. Okay, so now so 1 bit is nothing but 1 or 0, right? It can be either 1 or 0, right? Okay, so a 1 bit message can contain how many numbers, right? How many different permutations? It can either contain 0 or 1, right? So this is basically 2 to the power 1 2 to the power 1 numbers it can contain, right? So Boolean can contain only two numbers, right? Either true or false, right? It can contain either true or false, right? Whereas let's say a 2-bit message can contain how many numbers? It can contain 0 0 0 1 1 0 and 1 1, right? So how many numbers it can contain? It can contain 4 different permutations, right? Which is 2 to the power 2, right? So now a 3-bit message, how many numbers it can store? It can store 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1, right? So if you add all these numbers, so it can contain 8 different permutations, right? 8 different numbers. So this is basically the range, right? This is basically the range. So now a integer data type, right? Integer data type, which is 4 bytes, and every byte is of 4, it's of 8 bits, right? So how many total number of bits it can store? It can store 32 bits, right? So what will be the total range? What will be the total range, right? So if you look at this, right? So this is 8, which is 2 to the power 3, right? So if you have a 3-bit message, it is storing 3 bits, 2 to the power 3 numbers, right? 2 to the power 3 numbers, whereas 1-bit message can have 2 to the power 1, and similarly a 2-bit message can have 2 to the power 2. So now a 32-bit message can have how many numbers? It can have 2 to the power 32 numbers, right? It can have 2 to the power 32 numbers, right? So this is the range, right? This is the range of an integer data type, right? This is the range of an integer data type. What is the range of a double data type? It can have 2 to the power 64, right? So 8 into 8 is 64 bits, right? It can have 2 to the power 64 numbers, right? So now let's try to understand, right? So integer number, what is an integer number? Integer number is basically it can have negatives and positives both, right? It can have negatives and positive both, right? So equal number of negatives and equal number of positives, right? So it starts from 0, and ends at 2 to the power 31 minus 1. So if you add this, you will get 2 to the power 31, right? So similarly, all negative numbers, the range should be 2 to the power 31, right? So this is the entire range of a signed integer, right? So you also have unsigned integers. Only in C++ you have an unsigned integer where all the elements are positive, right? All the elements are positive, right? So signed integers, the range was this, right? Minus 2 to the power 31 to 2 to the power 31 minus 1, right? So this is the most negative value, but it can store, and this is the most positive value it can store, right? So the details, these things will be taught to you in details in the going forward assignments, okay? So now I'll just tell you that, okay, so there is a chart, okay? So a character can have 2 bytes, which is 16 bits, right? A byte can have 8 bits, which is one byte, right? A short can have 2 bytes. So these are basically numbers, right? These are numbers which you can have. See that 0 to there is a minimum value and a maximum value, right? So these are the numbers which it can store, right? An integer can have 4 into 32. So these are only for languages which support static defined data types, right? Static defined data types. Whereas other languages which supports dynamically defined data types, so the data type keeps on changing, right? So you can write x is equal to 5, and the next moment you can store, let's say, a double value, right, or a float value, and the next moment you can also store a string, right? Because during runtime things are getting executed line by line, right? Whereas in compile time, right, the languages which support compile time, okay, if you write int x is equal to 5, and so this x variable has been allocated a integer data type, right? So a 4 byte of space has been allocated to this particular x value, right? So now if you write double x is equal to 10, this will throw an error, right? It will tell you that, okay, I have already allocated a memory of 5, or like a memory of 4 bytes. You cannot change it, right? You cannot change it, right? You can change the value, but you cannot change the data type, right? Or even if you cannot write like this, right? You cannot write x is equal to 10, right? Because you cannot reallocate memory, right? Because once the memory has been allocated, you cannot reallocate, right? So this is one of the advantages of having dynamically defined data type over compile time data type, right? Static defined data type. Okay. So, but what you can do, you can change the value, right? So these things are not allowed. These things are not allowed, right? But what you can write is you can change the value, right? You can write x is equal to 10, right? So if it's of the same data type, you can store the values, right? So int x, that means you will be storing an integer data type, and you can store the values, right? You can store the values over here, right? So about operations and everything will be taught to you in the later set of videos. Okay. So I hope you have understood this. Okay. Any confusion, any clarification required, let me know. I'll be more than happy to help you guys. Okay. Thank you guys. Bye bye. Bye bye.